Good morning, class. Today we are going on to section 7.4 of your A-Maths, okay? And we are going to do areas of triangles and quadrilaterals, okay? Now, for areas of triangles, the formula is given on page 181. An area of triangle ABC is half. You write the first coordinate here, second coordinate, third, and then you go back to the first, where the points must be taken in an anti-clockwise direction. Note that it is very important that the points are taken in an anti-clockwise direction. Otherwise, this formula does not work. Now, these two lines are just symbols, so you just have to write it down. Now, I will give you an example of how to find the area of a triangle in the next question, in the next example. Okay? Now, if you look at this particular triangle, okay, now the 3 points are here, A, B, and C. You can go in any direction. You can start from any point, but you must go in an anti-clockwise direction. For example, I start from C. Anti-clockwise will be this way. So I must start from C, 5, 3, A, -2, -1, B, 2, -3, and you must end off with C again, 5, 3. This set and this set must be the same, okay? Then, how do we go about writing this formula? You put a half, you open a bracket, you take this times this, you get -5. This times this, you get 6, so you plus 6, you always plus. And this, you get 6, so you plus 6. Then you minus, you open the bracket, you go the other direction. -2 times 3, you get -6. Okay? -2 times 1, you get -2. And 5 times -3, you get -15. Okay? Now, you simplify this, you get this, you will get 15 units squared as the answer for triangle ABC. 15 units squared. Now, suppose you do not want to start from point C. You want to start from point B. It is also okay. You can even start from point A. It doesn't matter. But make sure you go in an anti-clockwise direction. So I will have B, C, A, but you must end off with B again. You do the same thing. You go this way. That will give you the first bracket. You go the other way. This will give you the second bracket. You minus, you will get this answer. Okay, let me just repeat. You take 2 times 3 to get 6, 5 times -1, -5, -2, -3 is plus 6, you minus, 5 times -3 is -15, -2 and 3 is -6, 2 and -1 is -2. Okay, you take the difference, you minus off, you get the answer is still 15 units squared. So, as long as you take the coordinates in an anti-clockwise direction, you'll be able to get the answer for the area of a triangle. Okay? Now, likewise, if we have an area of a quadrilateral, you are also to go in an anti-clockwise direction. Make sure the first and the last is the same point. Okay? And you can apply the formula accordingly. You can apply the formula accordingly. Okay, now let me just give you an example. For example, you are given this quadrilateral. I start from point S. So you go this way, S, P, Q, R, then S again. You cross 8, 9, 72, 18, this is 0, this is 6, put in the first bracket, minus the other way round. You get this answer. You simplify it, you will get a 55.5 unit squared. Okay, so that is how you apply this formula to find area of triangles and area of quadrilaterals, and it is actually called the shoelace method. It is actually called the shoelace method. Okay, so when we refer to shoelace method, we refer to this particular method here. Okay, now I am going on to the examples. Okay, that is example 12. That is found on page 181 as well. Now the question says that A 42, B negative 25, C 1K are vertices of a triangle. Given that the area of the triangle is 10.5 units square, find the possible values of K. Now, as I've said before, it's always good for you to draw a diagram to represent whatever coordinates that you have, to give you at least a gauge of what the diagram looks like. Okay? Now, don't forget, the triangle can be in two forms. It's either the C on top here, 1K, or the C below here, 1K. Alright? Now, some students will ask me, what if my diagram is not accurate? Okay? You just roughly plot the points. Okay? It's just a gauge for you. Okay? For you to visualize where the coordinates are. Now, first of all, I take this C that is above AB. I go anti-clockwise direction, so CBA. So CBA, I must end with C again. They tell you that this area is 10.5. Now we do the same thing. Go this way, I get this. Go the other way, I get the other one, 10.5. You do the necessary manipulation, you will get your K as equals to 7 for the first case, where C is above AB. Now, of course, there is a second case whereby the C can be below. Okay, look at this second diagram where the C is below. Now, if the C is below and I take A as the first point, I will go in this direction. This is anti-clockwise. So I will get 4, 2. All this end with 4, 2. Remember, the first and the last point must be the same. So I go this way, put in the first bracket. I go the other way, put in the second bracket. 10.5. I simplify, I manipulate, I calculate, I will get K equals to 0. So for this particular case here, you have two answers. K is either equals to 0 or K is equals to 7. Okay, so this is your example 12. Okay, now example 13. Let's move on to example 13. Now, example 13 says that the diagram shows a rhombus ABCD. Alright, rhombus means it's a parallelogram with all the four sides equal. The point A is so on and D lies on the y-axis. The equation of CD is given and the equation of BC is also given. Find the coordinates of D. Alright, now I want you to take a look here. The equation of CD is known and it intersects the y-axis at D. Okay, so for the first part of the question, when it intersects the y-axis, that means x is 0. So when x is 0, y is 2. So I will get D as 0, 2. So this D is 0, 2. It's very straightforward. Now, next, they want to find the coordinates of C. Now, note that this line, I'm going to draw here, this line CD and this line CB meets at C. That means this is the point of intersection. I just need to write this equation and write this equation. I solve these two simultaneous equations, I will get the coordinates here for point C. So I write the two equations down. I solve it simultaneously. I will get x as 1 and y as 4, and I will get your C as 1, 4. The coordinates of C as 1, 4. Okay, using simultaneous equation. That means when I solve a pair of simultaneous equation, the point of intersection lies on the two lines, so it will represent the point C. Now, part 3, what did they say? Find the coordinates of B. Now, realize that this is a rhombus, which is also a parallelogram. The midpoint of DB is the same as the midpoint of AC. Now, let's find the I let B, they say they want to find the coordinates of B. I let B be PQ first. I let B be PQ. Alright? Now, then I find the midpoint of AC. I take the coordinate, the x coordinate, add together, divide by 2. The y coordinates add together, divide by 2. This is the midpoint. And don't forget, the midpoint of AC is the same as the midpoint of AC is the same as the midpoint of, I think I made a mistake here. The midpoint of AC is the same as the midpoint of DB. BD. This should be D. Okay? So I have 0 plus P over 2 is equals to, and 2 plus Q over 2. Okay? Now, this and this is the same, so I equate. This and this is the same, so I equate. I will get P as 3 and Q as 3 as well. Okay? So my final answer will be B as 3, 3. Okay? Last part. Hence, find the area of the rhombus. Now, we already know all the 4 coordinates of the 4 corners. So we just apply the area formula. Remember, you start and end at the same point. So I apply the formula. I will get a 5 unit square for example 13. 5 unit square for example 13. Okay? Now, questions on chapter 7 are usually quite long, but as long as you pay attention, you'll be okay. Now, I just want to reiterate, when you solve 2 simultaneous equations, this point will be the point of intersection, and this will be the solution of the 2 simultaneous equations. So bear in mind, if you want to find the point of intersection, you just need to find out this equation and this equation, and you solve it. It will give you the coordinates to the point of intersection. Okay? That will be your example 13. Alright? That will be your example 13. Feel free to repeat the video if you cannot understand some of the parts. Okay, I'm going on to the last example, that's example 14. But before I deal with example 14, I need to go through a certain concept here. Now, I want you to look at this triangle here. Now, let's take a look at triangle A, which is this. Now, do you agree that triangle A, the area is half times A times H? And the area of triangle B, which is the red one here, is half times B times H. So area of A over area of B is this. And you can see that I can cancel the half and the H away. And the ratio of area of A to the ratio of the area of B is actually A over B. So area of A is to area of B is A is to B. Now, you will realize that these 2 triangles that actually share the same height. So what does it mean? Ratio of the areas is equal to ratio of the bases when the triangles share the same height. That means, if I have 2 triangles, let me just draw this again. If I have 2 triangles and they share the same height, okay, let's say this is C and this is D. This is triangle A and this is triangle B. So area of A over area of B is actually equals to C over D. Okay, C over D. Now, let me just give you another one. What if I want to find the area of this big triangle, the whole green one, okay, that we have here? Let me just highlight it again. I want to find the green one here. What is the area of A over the whole triangle? So I will have area of A over area of, let's call this big triangle capital C, or maybe X. Let's call this triangle X, this big one. This big triangle, we call it X. Area of X will be, now area of A, this is the base, C. Area of the whole thing is actually C plus D. Okay, that means if I were to prove it, okay, the area is actually half times C times H, whereby the height is H, over half times, now can you see that if I have the big triangle, the base is actually C plus D, and I times H. This H and this half cancel, therefore I get C over C plus D. So what does it mean here? It means that if 2 triangles share the same height, the ratio of the areas is just the ratio of the bases. Okay? Alright, if you take this over this is C is to D. If you take this over the whole thing is C is to C plus D. Okay? Alright, so this is a concept that you must know before I can do example 14. Okay, let's take a look at example 14. Alright. Now, before I go on to example 14, I need to revise two things. Parallel lines have the same gradient. Okay. Perpendicular lines have gradient which product gives you -1. This is what we learned in the previous section. Okay. Now, if you look at example 14, it says, alright, it says, the diagram shows a quadrilateral ABCD with vertices at A, B, C, and D all given. The point P lies on the line AB, okay, such that DP is perpendicular to AB. Alright. The line DP and AC intersect at point Q. Okay, find the equation of AC. Find the equation of AC. Now, this is easy. We just need to find the gradient of AC. Okay, then remember I gave you the formula. Y minus the y coordinate of the point that it passed through equals to gradient times x minus the x coordinate that is passed through. So I simplify. This will be the equation of AC. Alright. Now, part 2. They want you to find the coordinates of Q. Now, if you look at the diagram, Q is at the intersection of DP and AC. So if I'm able to solve the equation for DP and AC, I can get the point of intersection Q. Now, I only know the equation for AC. I do not know the equation for DP. So I have to find the equation for DP. Now, we know that DP is perpendicular to AB. So gradient of AB is this. So gradient of DP is -1. Because when the two of them multiply, it must give you -1. So equation of DP, I will apply, because it passed through the point DP, it passed through the point D. So I will use the formula and I will find this equation. So I will have to solve this and this simultaneously, okay, to get x equals to 3 and y equals to 1 to get the point Q. The coordinates for Q, which is 3, 1. Okay, so I have already finished part 2. Now part 3, they want to find the ratio of QC to AC. Now, this one we have to get the length formula, the line segment formula, the length of line segment. QC, I apply the line segment formula. I simplify, I get 2 root 30. I find AC, I apply the line segment formula. So I get this, I get 3 root 30. I equate it, I put it in terms of ratio. I simplify it, it will be 2:3. So this will be the answer for part 3. Now part 4. Find the area of triangle ADC, hence the area of triangle QDC. Now I'm transferring the diagram here so that you can see this triangle ADC and Q here. Now I want you to realize that for this particular triangle, this is the height that they share. Okay, now area of triangle ADC. ADC is the whole thing. Okay, ADC is the whole thing. Alright. Now in part 3, we know that QC is to AC is 2:3. Okay. So in part 3, we know that QC is to AC is 2:3. So QC is 2 units, AC is 3 units. It follows that AQ is only 1 unit. So it's 2 unit, 1 unit here. So area of triangle ADC is the whole thing here, so it's 3. Area of triangle QDC is 2 units. Okay. Now, first of all, in this part here, I find area of triangle ADC using the area formula. Okay, area of triangle ADC using the area formula, I will be able to get 37.5 unit square. Now because of this, I can write area of triangle ADC over area of triangle QDC is actually 3/2, because the areas ratio is the same as the ratio of the base. So I substitute in what I know, I cross multiply, and I solve for the area of triangle QDC. Okay, so it's quite a long-winded question, but we can get the answer immediately. Okay, if we apply it and have patience and resilience in the way that we solve the questions. Alright, so this will be your example 14, that is for section 7.4. Now next, I'm going to give you homework. Okay, I'm going to give you homework that is for your notebook as well as your foolscap paper. Okay, for question 6, you will do it in the notebook, and for question 4, 5, 8, 10, 11, and 14, you will do it on the foolscap paper. Okay, now as I said before, do not check the answers until you have finished doing your work, or you need to get some hints to how to continue to do the questions, because ultimately in the exam nobody is going to show you the solution. Okay, now let's look at notebook question number 6 first. Alright, question 6 says, find the area of the figure bounded by the points A, B, and C. What can you say about the points A, B, and C? Now, you roughly sketch the 3 points out and you apply the area formula. You will realize that the area is actually 0. Okay, you will realize that the area is actually 0. Now, for 3 points and the area is actually 0, it will only mean that the 3 points actually lie on the same line. That's why there's no area. If they do not lie on the same line, then there must be some area. Okay, so they say, what can you conclude about the 3 points? You just have to say that the 3 points are collinear. The 3 points are collinear. So this is another way to prove that 3 points are collinear. You can find that the area is 0, therefore the 3 points will be collinear. Okay, that will be your question number 6. Next, I'll move on to question 4. They gave you the coordinates of the vertices of a pentagon. Now, pentagon is 5-sided. That means there are 5 vertices. Okay, find the area. What we need to do is that we will have to apply the area formula. Okay, and do it slowly, then we can get the answer. Now note that when we apply the area formula, all the coordinates got to be taken in the anti-clockwise direction, and the first and the last must be the same. Now since there are 5 vertices, there must be 6 here. 1, 2, 3, 4, 5, 6. The first and the last must be the same. We do accordingly. Okay, the other way around for this, and we'll get 38.5 units squared. That is your question number 4. Next, we go on to question number 5. Okay, let's go on to question number 5. Question number 5 says that a quadrilateral has vertices so on and so forth. Find the area in terms of t, where t is bigger than 0. Okay, since t is bigger than 0, it means that t got to be on this side. Okay, so we plot roughly the points, and then we go in the anti-clockwise direction. We apply the formula. We will get 12t plus 30 units squared. That will be the area in terms of t. Okay. Now next, question number 8. Question number 8 is similar to one of the examples. The vertices of a triangle are so and so forth. Given that its area is 24 square units, what are the possible values of k? Now for question 8, you have to draw the diagram. The Q can be on top or the Q can be below. If it's on top, we do it this way. Take the coordinates in anti-clockwise direction. You equate to 24. You solve, you will get your K as 8. Now if Q is below, this is the working. Okay, you solve and you will get your K as negative 2 over 3. So the answer is 8 or negative 2 over 3. Now you can also leave this answer as negative 8 over 3. It doesn't matter, but you have to give it to lowest terms. You have to give your answers to lowest terms. So that will be your question number 8. Okay. The next question is question number 10. Okay, question number 10. Now, it's always good to draw and label the diagram so that we can understand the question. Now, the whole question, the diagram shows a kite A, B, C, D, alright, so on and so forth, and the diagonal AC bisects the diagonal BD at right angles. So, find the equation of AC. Find the equation of AC. So, let's find the equation of AC. First of all, we find the gradient of BD first, which is half. And since AC is perpendicular, we can get it as negative 2. Then the midpoint of BD will be the same as midpoint of AC. So we equate, it passes through the midpoint. Okay. So let me just repeat. The gradient of BD is this, the gradient of AC is this. Now, because this AC passed through the center, it bisects, so it must pass through the midpoint of BD. I go and find out the midpoint of BD, which is 2, 5/2. So let me repeat again. We find the gradient of BD, then we get the gradient of AC, and we find the midpoint of BD because the line AC passed through the midpoint of BD. So we apply y equals to y minus 5/2 equals to negative x minus 2. Y minus the y coordinate equals to gradient times x minus the x coordinate. This is the point that it passes through. So the equation of AC is actually this particular value. Okay, the equation of AC is this particular equation. Alright, now part 2, they say hence find the coordinates of A and of C. Okay, now when x is 0, I will get C. So C is just 0, 13/2. When it's at A, the y is 0. So I plug in, I will get x is this. So A is 13/4, 0. Alright, they say hence find the area of the kite. Since we already know all the 4 coordinates, we will apply the area formula, okay, in an anti-clockwise manner. Go this way for the first bracket, this way for the second bracket, and the first and the last coordinates must be the same. We will get 1/8 units squared for the area. That will complete your question number 10. Okay? Now, question number 11 and question number 14, the next 2 questions are very common in the O levels, so I want you to pay special attention. Okay? Alright, let's look at question number 11 first. Okay, what did they say? The diagram shows a rectangle. Okay, the side AB has this particular equation, and the side AD has this particular equation. Find the coordinates of A. Now, this side has this equation, this side has this equation. A is intersection. I will solve the 2 equations simultaneously. Alright, I will solve the 2 equations simultaneously. Okay, now after I have solved the equation simultaneously, I will get your x as negative 2 and your y as negative 5. So the coordinates of A is actually negative 2, negative 5. Okay, next they want to find the coordinates of B and of D. Now first we got to find the coordinates of D first. Now let's take a look at this particular side. Now you must find the coordinates of D. D is at the intersection of AD and CD. So I know the equation of AD, I must find the equation of CD first in order to get the coordinates of D. Okay? Alright, so let's take a look. Let me just show you the diagram first. Okay? D is at the intersection of this line and this line. Therefore, I got to find the equation for CD. So I know this is the equation for AB, and AB is parallel to CD. AB is parallel to CD, therefore they have the same gradient. So I write it in y equals mx plus c, so the gradient of CD is actually negative 1/3. That means here, because they are parallel, they have the same gradient, and because CD, it passed through the point C, 4, 3, I substitute here, I will get this particular equation. Okay, now this is the equation for AD, this is the equation for CD. I solve them simultaneously. I will get your x as 1 and your y as 4, and I will get your point D as 1, 4. Okay, point D as 1, 4. Now after I find this, then I can get the coordinates of B straight away over this side. Now realize that in this, the midpoint of AC must be the same as midpoint of BD. Midpoint of AC, I apply the midpoint formula. I let B be PQ, this is D. This midpoint, the midpoint of BD is the same as midpoint of AC. I equate them, I solve them, so I will get your B as 1, negative 6. BD as 1, negative 6. For the last part, part 3, I'm just applying the area formula. Okay, you apply it in an anti-clockwise manner. Don't forget the first and the last must be the same, and you will get a 30 unit square for question 11 part 3. Okay, Now, question 14 looks very long, but actually question 14 is actually very simple. Okay, so you need to have perseverance when you do this type of questions. Okay, now let's take a look at question 14. Alright, question 14, which is the last question. Okay, question 14, which is the last question. Alright, it says that the diagram shows a quadrilateral OPQR. The coordinates of P are so and so forth, where A is bigger than 0. The length of OP is 6 root 5, show that A is equals to 6. Now we apply the length of line segment formula. We equate it to 6 root 5. We square both sides, we will get plus minus 6. Since A is bigger than 0, I will conclude that A is equals to 6. So we have already shown that A is equals to 6. That's a part 1. Okay? Now part 2. PQ is perpendicular to OP and Q lies on the y-axis. Find the equation of PQ. Now, gradient of OP is this. So gradient of OQ will be negative half because they are perpendicular. So since I know it passes through the point P, which is 6, 12, because I already know that A is 6, I subs in. So I get the equation of this. Okay, so the equation of PQ is just this particular equation. Okay, next, the coordinates of Q. Now, the coordinates of Q is here. Can you see that PQ, when x is 0, I will get the coordinates of Q. So I will substitute in. When x is 0, y is 15, so coordinates of Q is 0, 15. Alright? The point R lies on the perpendicular bisector of PQ. Okay, the point R lies on the perpendicular bisector of PQ. Given that the line OR is parallel to the line this, find the coordinates of R. Okay, now, can you see that I need to find, if I want to find the coordinates of R, I need to find, first of all, the equation of the perpendicular bisector of PQ first. Now, midpoint of PQ is this. Gradient of PQ is this. So the gradient of the perpendicular bisector will be 2. And it passes through this point. I plug in the formula. This will be the equation of the perpendicular bisector. Okay? This will be the equation of the perpendicular bisector. Okay? Now, next, I'm going to find out the equation of OR. Okay? I need to find out the equation of OR because I need to solve the equation of the perpendicular bisector with OR. Okay, then I can get the coordinates of R. Okay, now we know that OR is parallel to this particular line, so I'm going to write it in the gradient intercept form, and I know that the gradient is negative 11 over 2. Negative 11 over 2. Now, can you look at the line OR? It passed through the origin. Therefore, C must be 0 because the y-intercept is 0. So I'll get these two equations. So this is the equation, okay, for the perpendicular bisector. This is the equation for OR. I solve these two simultaneously. I will get these coordinates for R. Okay, now I'll repeat again. The point R lies on the perpendicular bisector of PQ. Okay, that means R lies on the perpendicular bisector of PQ. And given that the line OR is parallel to this line, so I need to find the equation of OR. Okay, so when we find the perpendicular bisector of PQ and the equation of OR, when we solve them simultaneously, we'll get the coordinates for R. The last part, the area of the quadrilateral OPQR, you just need to apply the area formula accordingly, and then you get your answer as 52.5 units squared. Okay, now class, for this kind of questions on coordinate geometry that is on your chapter 7, what you need to do is to be very clear what you are finding, apply what you know, apply all the concepts that you know, and plan your answers so that you can get the correct answers and do not make any careless mistakes during the way. Okay, so that will conclude your section on 7.4. Thank you, class.